So here we have the imputer. So we're going to use simple imputer to get rid of non-values for the categorical data. And we have defined the categorical data in here as D. And then we use this library, simple imputer, to get rid of the non-values. And we're going to use, last time we used the mean value for the numerical data, but here we're going to use the most frequent data to populate the categorical value. So you see the D is the categorical value. We'll see how that works. So you see before that we had a non value here, but at the moment, so it's going to populate with the most frequent value. So you see the most frequent value would be the London, and then it got populated with the London value, right? So that's about populating the missing data with the mean value for the numerical data, and for the most frequent value for the categorical data, right? So the next thing is we're going to use one hot encoder. So what it does basically, we need to scale it down and also convert this categorical data to the numerical data. So that's the plan, and we can use a library called one hot encoder. So we will pull that out, one hot encoder, and assign it to encoder, so we can run that and see. So now we have a encoder so that we can scale these things up. And what we're gonna do, we're gonna reshape this data set, then we can fit this to a machine learning model. So that this is the code that I will be using here, right? So basically I'm going to create D2, and already we have the D categorical data here, and from D all rows and the 0 column, and we're going to reshape it around -1 and 1, right? So the one encoder object fit to the D2 and transform the data here, right? And then what we're going to do, we're going to use this D2 to encode and convert it into array. So basically what we are doing with what we are trying to do here is, get the categorical data and put it into a numerical data, right? So now what we're going to do, we're going to encode it and then D2 to an array, right? So that's what we've done here. And also we are going to concat. What does it mean by concat? We're going to add the column 1 and 2 as well here. And then we're going to check out what D looks like now, all rows and then the first column, right? We'll see what we come up with, you see. So now we have basically done the first 0 column and put it into a you see, before that it was male female. So we have converted into a numerical value right now, right, using this process. And this is how I done it, and you can use that. So now we have a categorical data set into a numerical value. So basically we replace a male for male 1 and female 0, right? Cool. So we've done that for male column, gender column, but we've got another column to do. We're going to use the same one hot encoder to do that, right? So we will do that, and so we're going to do column 2 now, right, which is the location. So, and it's going to reshape it around -1 and 1, and also we can use the one hot encoder fit transform D2, and we're going to put it into an array, right? So, and then we assign it to D3, and then we concat that, we add that 0 to 0 1 0 to 2 column. So basically we are adding 1 and 2 here to the new column, right? So once we add them, so we have a new D value, we can print it and see what it looks like. Now we have all the categorical data under numerical values, you see Dublin, London, so we have a values for that now instead of a categorical value. So that's how we change categorical data to numerical data. Cool, so we have done that piece. So we're going to do feature scaling now. So we did data cleansing with the one hot encoding and then the simple imputer. Now we're going to do the feature scaling, right? So I'm going to make this a heading, so because it's the second stage that we're going to do feature scaling. We scale this data now, right? So we can use this code snippet to do that. From SK library, we can use standard scaler to scale our data, and we're going to call standard scaler as SC, and we're going to use all the feature data from all rows from 0 to 13 column. You see in 0 to 13 column up there. If I go up 0 to 13, right? So, and then diagnosis is your target data. So and scaling using standard scaler SC fit transform all rows 0 to 13, and then we will print out the row 1 and column alls, right? So we'll see what it looks like. So we use the column 1 and all columns, sorry, row 1 and columns. So it looks like it's scaled down now, right? So before that, if you check it, the numbers are high, like 590, 450 minus, but now we have scaled it down to a small number, like then it's easier for us to feed into the machine learning and work on the matrices, so that it doesn't take much of computer processing power. So we have done the feature scaling now, so now they are scaled down, so it's easy to do the process, right? So we'll go and check all these values using this whether it's done the job for us. So we can use to find the mean value of this all the columns from 0 to 13 with this command. So we can see, so it should give us 1 because that's scale up to 1, right? So sorry, so there's no so the mean would be zeros, right? So there's no different changes on that. So we have done that. So it looks like we have scaled down, we have done this feature scaling, and then finally we're going to do the feature selection, right? Now finally, before splitting the data, we're going to do feature selection. So we do feature selection here. I'm going to make a new heading for this, and then for the feature selection we can use this. So we're going to use select the best K. Remember earlier I was talking about the K-fold cross validation. When you have a training data set, we're going to use portion of the data set to test in, and the other portion is to train the data. But what does, and then I explain what the K-fold value is, K-fold cross validation is. Instead of using the same test data and the training data for the each iteration, we are swapping the test data like this. So here we initially use this portion as the test data. Now for the second iteration, we're going to use a different portion of the test data from the whole data set. So this piece becomes your new test data, and the rest would be your training data. This is the process that we're going to code it right now. So that's where the K means K cross validation comes into play. So and also we need to identify what is the best K for this particular problem. So at the moment we are using case 11, and then we checked out what would be our feature data set looks like, right? So let's see. So in here, so we print out X, and we have using K-fold cross validation in here, and then we're going to use finally we're going to use the uh, split the data, right? So we're going to split the data. We can use splitting the data is the second thing we can do. So I'm going to make another title in here. And again, once we split the data, we can use a portion for the testing and the other portion for the training, right? So we can use a scalar and model selection, import train and test plate. And here we have xtrain, xtest, ytrain, ytest, test the model and the train the model. And we can use train test split for that. xy, x is the feature. Dataset y is the target data, and here we're using a 0.1, which means like, you know, we're going to use 10% data for the testing and 90% for the training, right? And you can also see the size of the the train data. If I do this len command, so you see what the split looks like. So extend, you have 252 rows. So I do the same thing for x test. So it should be 1/10 of that, right? Not 1/10. This is the 90% of the data. The rest would be 10% of the data for testing. So we have 40 for testing and 352 data rows for training. So we're going to use k-fold cross validation, and k we're going to use 10 here. I'm going to make another heading here. So for that, we can use this code snippet. Alright, so I'm going to use here the first one is Gaussian NB, which is the Gaussian base naive base model that we are importing. And from a scalar and model selection, we can use the k-fold cross validation library, and here we can use the select the best k in as well. So in here we're going to use k-fold for 10, right? So let's go back in here and see. So we're going to use 10 for k, and also for the modeling machine learning model, we use Gaussian NB, which is the naive base, and we're going to use 10 k as 10 for the folds, right? You know, training and test data, and we can see the score of that, right? So we're going to print it out, the score like, you know, the accuracy of the model. So different case, different accuracy. So I think the best accuracy you get is this one, right? I think that would be k equals 9, I think, right? But pretty much these ones are pretty much good. So anything above k equals 5 or beyond, it's good, right? So that's what we have done for the k-fold cross validation, and these are the accurate results for your model using the k-fold cross validation, and score is given, so you can use the score to identify the best k for your model.